This is Kate BYP in this engineering shop of horrors, looking at the thermal expansion valve. I bought two of these surplus for $35 a piece. They're normally $200 to $300. To be able to take off this new power head, this new thermostatic assembly from this valve, because this is exactly the right thermostatic assembly that would go on my heat pump. What happened with it is that this capillary line broke off right here at this bulb because this tubing was improperly installed at train, and it's easy to stop a train by doing bad assembly work because that line was left to flutter in the airflow leaving the evaporator and broke off at the bulb. It's unforgivably poor manufacturing. Just because that tube's broken does not mean it's necessary to change that. There's nothing wrong with that. And I proved that with my experiment of putting pressure on this line, and the valve worked. Replacing this body requires evacuating the sealed system, unsweating these two lines, taking the old one out, sweating these two in new, and recharging the system. It's a whole lot of work. Basically, a DIYer would take several days to do it. It might take a good part of the day for a good HVAC mechanic to do it. So, having this leaves me two options. Put air pressure on the existing broken line, or drop the pressures in the sealed system, unscrew the original, and screw this one on. There's going to be refrigerant loss when that's done. But there's a way to do it that might be surprising. There's a way to do it with very little refrigerant loss. This video is about what this valve does. This valve is a control. It uses a difference in pressure between the pressure in this bulb here and the pressure on the outlet of the indoor coil in the heat pump. This is the one that works for the cooling mode. There are two of them in this system. This one is located near the evaporator for cool mode. The other one is located up underneath the outdoor coil fan, and it's for the outdoor coil for heat mode. In the opposite mode, these valves bypass, don't do anything. The definition of control is a small force or a small input that affects the quantity or operation of a larger flow or output. And here this valve controls the flow of fairly high pressure refrigerant through this pipe, through the valve, past a piston, out this line, or that way, whichever. There's a piston in here on a push rod that goes up and touches the bottom of a diaphragm in here. As you can see, that head is not symmetrical, it's dished downwards. When this tube's broken, that diaphragm's pushed all the way down, pushes the stem down, closes the valve off. I did an experiment to try to change the pressures on here with an air compressor to see if I could measure the position of the pin. There's no way to do that by taking this cap off and measuring the pin. Correction. I put pressure on the equalizing line to push the diaphragm up and release the pin up by the spring inside, and that increases flow. When this tube is broken, let's make sure I have this correct. With this tube broken, there's no flow. The pressure here is higher. So the higher pressure here pushes up on the diaphragm. The pin goes up and closes the valve off. So I put on the failed one in the heat pump unit, I put pressure on this line, pushes the diaphragm down, opens the valve up. So on this new one, I put pressure on this line to see if I could raise the diaphragm and measure the amount needed at about the low side pressure. The amount of pressure here to move this up into an operating position. I was unable to measure that because my compressor won't go high enough. And when this pressure on this line is above about 45 to 50 psi, the pin lifts up and starts bypassing some pressure out this opening down here. So I was unable to test that the way I wanted. What I was able to prove is that there's about 45 psi left on this port. When this pressure drops, the diaphragm goes down because of this pressure and shuts the valve off. And that just happens to be slightly less than the minimum operating pressure in the sealed system, because at 50 psi exactly, the low side pressure cutout opens. So that suggests this new valve is working correctly, because it has about a 45 psi minimum pressure. There's what's inside. There's a view you would get with a similar valve going out and unscrewing the cap. There's the diaphragm in there. It's pushed all the way this way. There's the pin. It's rough on top. Little mark in there where it's been pushing. But push that pin down, the valve opens. If you want to change that control head, this part, that can be done contrary to the opinions and the false statements of the people in the HVAC world that demand you must discharge and recover the system and replace that head and recharge it. That is false. They're telling you that out of ignorance, and they're telling you that out of greed, because they want to be able to charge you another $400 to go out and recover that system, then recharge it later. In other words, they're out to screw you just because you don't know any better. They will not do so to me, because I can design the heat pump. This thread is very deep. It doesn't want to stand up. See how deep the thread is? Even with pressure pushing that pin up from the spring inside, it is easy to start screwing this on, and it will thread on till about that far from touching the pin. So it's not going to be a case of taking this off, let something pop up so you can't get this back on. They were smart enough to make sure that wouldn't happen. But what's going to happen is this little hole here, if the sealed system is pressurized, is going to bleed refrigerant vapor. With pressure in the sealed system, this line on my Train XL14 heat pump is soldered into the outlet of the compressor, which goes, or the outlet of the evaporator, which goes to the inlet of the compressor. That pressure can be as high as over 200 psi when the system's off. That would bleed a lot of vapor out that hole. I calculated that with 170 psi of vapor through about a 60 thousandths ID tube, 36 inches long. I used a calculator online, but I calculated that port would discharge something like 5/8 of a cubic foot of vapor per second. That's a fair amount of vapor. It might be necessary to replace some of it afterwards. And don't believe the lies that people in the HVAC world are telling you that it's illegal for you to discharge or buy or use R410 because you don't have a license. That's two lies. Number one, there's no such thing as a refrigeration license. EPA regulations say it's a certification, not a license. And secondly, EPA regulations exclude R410. They're lying to you to trick you into thinking that they have to do the work and charge you 3 to 5 times more money than what you can do it for. And I know the heating and air repair business. I was in it years ago. Then I moved into controls engineering. But anyway, there's a trick to it. With this line broken, start the heat pump up and cool. This valve is closed. The low side pressure drops like a stone down to 50 psi. Pardon the cough. We still have the smoke in the air from Canada. But the low side pressure drops to 50 psi when the low pressure cutout opens. And it'll stay rather low for quite a few minutes. 50 psi on that means much less vapor being discharged through that hole. It's going to lose some. Losing a very small amount is a whole lot less trouble than having to completely dump that system and recharge it. hours to do that. So the thing to do is get these special wrenches from Harbor Freight. This is a service wrench set. For this particular TXV, it's a 1 1/4 to fit on, let's see, 1 1/4 to fit on the nut on the control head, 1 1/8 to fit on the body. And be extremely careful. There's not much room on that body to get a wrench on. Don't break any of these lines, because damage that line or those lines and you will have to dump a system and replace that. But have to use those wrenches and be careful. Don't try to unscrew that by hand by pushing on 2 wrenches. That's going to jerk that copper plumbing around badly. What I'm going to do is take these 2 wrenches and weld tabs on them and put a forcing screw between them. And there's also not much room in there to reach in. I can't reach in there with both hands because they've got this TXV in a small compartment. That would require taking the divider between the evaporator and the compressor compartments out, and it's in there pretty good. So I don't want to tear the cabinet up to do that. So I'll just make a forcer for those wrenches. But crack that cap loose, you'll immediately start hearing a little bit of refrigerant escaping. Get the new one with a line coiled up like this, and as fast as you can, unscrew the old one and perhaps put your finger over the port. There'll be a very small force on that port of maybe a few pounds. Because remember, the relationship between pressure and force. Pressure equals force over area for 50 psi, and the area, which is pi times d, I believe, or is it pi r squared? I think it's pi r squared. The pi r squared for a 60 thousandths hole is a rather small area. That rearranges to force equals pressure over area, and the pressure of 50 psi over an extremely small area is a very small force. So you'll easily be able to stop that vapor flow with a finger, maybe a piece of tape, and then quickly as possible screw this on. This ain't rocket science. Over the, I don't know, 4, 5, 6 seconds it takes to change it, there'll be a minimal loss of vapor. It's no big deal to put an ounce or 2 back in. My heat pump is charged with 7 pounds, 8 ounces. If it loses 2 ounces, I could care less. It's oversized for the addition in the house anyway. It's a 3-ton unit on 950 square feet. It's badly oversized, so not a crisis. I'd rather lose 2 ounces that I don't need than spend all day doing work I don't need. What this TX valve does is regulates the pressure and the flow, or actually the pressure of that outlet from the evaporator. And this set of wavy lines might represent the pressure varying around. And what the valve does between these 2 lines is cuts off these variations, or at least tries to keep conditions constant, as in between these 2 lines. So it's not working in this region. It's working out here in these small regions. So control is small forces here and here affecting a large force in there. The way to get the proper replacement control head is by the numbering on top. That's a Sporlan TXV. Sporlan is a division of Parker Hannifin, a controls division. And that's Parker's nomenclature, 45ZGA 31414. That's a 45ZGA, a thermostatic assembly. Z means R410, and GA means, I think it's a refrigerant cross charge in this bulb. And you can look up Parker's data for that online. I don't remember what the 45 means. But to get this head, all you've got to do is get the correct number off the top of it. It doesn't matter what that is. So these things are almost $200 to buy them online. I bought this whole unit surplus for $35. Thanks to Joe-flation, things are expensive, money's kind of tight. It behooves us to do it ourselves. $1,000 to the heating and air man, or $40 and some elbow grease for this method. I'm going to use this one. In fact, I'm initially going to be cheaper, and I'm just going to put air pressure on this to see if it works. Because people say it can't be done, I'm going to prove them wrong. And I have the engineering ability to do so. Another caution, don't destroy the sealed system. That's a non-adjustable valve. It's a short cap. Parker came out with later versions that had a step down here and then another step. Those are adjustable. Under no circumstance reach inside that sealed system, inside that unit, and try to unscrew that. That's brass on brass. Brass has a very high coefficient of friction. I had to put this in a vise and reef on it with a 1/2-inch ratchet to get that loose. You try to twist it off with a ratchet, you're liable to break those pipes right off. Not adjustable anyway, don't mess with it. You'll be crying the blues if you twist that and crack one of those lines, because you'll lose all the refrigerant. And that's $150. So, as to putting air pressure on here, it should be possible to go up to probably 100 to 150 psi range of air pressure, which is countered by in my heat pump, a nominal about 155 psi on the low side in cool, with 70 degree entering indoor air. That means the air temperature coming in the evaporator. So a pressure of 67 psi on here was enough to set the low side higher than the low pressure cutout. So the system came on and ran. Of course, at 67 psi, it's probably quite low and probably won't be much on the low side pressure, but it proved that method works. So what I'm going to do is slowly increase the pressure on this broken capillary tube on the unit in my heat pump with an air compressor and a regulator. I'll regulate it through my service gauge set. Start at about 40 and start working up while the thing is running and while I'm monitoring the low side pressure. And I'll be aiming for a little bit less than 155 psi on the low side, maybe 120, and just see how it works. Again, a 3-ton unit for 950 square feet. Somebody put a heat pump in, it's way too big. So what do I care if it knocks off 30 pounds off the low side pressure? It's going to mean lower system pressures. Why would I care? So there's a TXV story. KBYP did it.